You are watching Darasa Online.
Hello out there, it's Darasa Online again, and let's discuss again mathematics, advanced mathematics. And our topic today, as it's seen out there, is trigonometry, and subtopic will be compound angle formula. And the presenter of today, or the teacher that will be teaching you today, is Kimati John. Welcome and be with me from the start up to the end of the session. We will cover the following. We try to derive some compound angle formula, but I will not derive as derivation it is. I will try to remind you what are compound angle formula and how do they look like. And we shall try to prove some identities involving compound angle formulas, and then after that we shall simplify some few identities that involve compound angle formula, and then after that I will leave you some more questions for you to practice. But use much more careful these questions that I always left for you to practice, because they are not the only questions that are out there. So please find more questions and practice on them. Welcome. Okay, now let's see the definition of compound angle formula. What is a compound angle formula? Compound angle formula are formulas which describes the combination of two or more angles into a simple form. I will repeat that. Compound angle formula are formulas which describes the combination of two or more angles into simple forms. And we know that we have three compound angle formulas, major compound angle formulas that will involve sine, cosine, and then tangent. Sine, cosine, and then tangent. And let's see those compound angle formulas. Let's remind ourselves. Now we have compound angle formulas for sine. Let's say we have sine x plus y. That means this we know that it will be sine x cos y plus sine y cos x. And so as to the sine x minus y will be sine x cos y minus sine y cos x. So we know that we have sine of x plus y is equal to sine x cos y plus sine y cos x. As you can see, they have changed the position. We had sine y and then sine x, then cos y, and then plus where it was sine x, now it is cos y, it is sine y, and where was cos y, now it is cos x. So what if you have, let's say, sine x plus x? Then you will be having sine x cos x plus sine x then cos x. And then simplifying that, you will see that you are going to end up with sine x cos x. That is some simplification and some more identities. That means sine 2x is equal to that thing, and this is sometimes so-called compound angle formula or double angle formulas, and we will see that in the next lesson. But today we shall focus on compound angle formulas. Now let's say sine x minus y. We know that this equals what? To sine x cos y minus sine y cos x, and that is how it is. So remember that how it is presented, so that you can use that into different expression or different simplification. That was for sine. Now let's see for cosine. For cosine, we know that we have cos x plus y. This equals to what? Equals to equals to cos x cos y minus, it was plus but it becomes minus, then sin x sin y, sin x sin y. What if now we have cos of x plus x? That means we have cos 2x. That means you are going to be left with cos x again minus sin x sin x. That is to say we have cos square of x minus sin square of x. You can simplify that the way you like, by the use of Pythagorean identities, by the use of whatever you can do, so that you can simplify that more and more and more, and you can use those identities into different kind of questions and to different kind of situations, For example, there we can go more. Let's say you can say it's 1 minus, we know that from Pythagorean identity from the last lesson, minus sin square of x. That means equals to 1 minus 2 sin square of x. One can say that, and then equals to what? Cos 2x. This will be we can find the value of sine. That means it will be sin x square, 2 sin x square equals to what? 1 minus cos 2x. And then from there, you can just play with that. Sin square of x equals to what? A half. These are different identities that are very much useful while doing questions, especially in integrations, as you know. So you can use that as the way you like and the way you like. So that was cos x plus y. What about cos x minus y? This equals to what? This equals to cos of x cos of y. Then where it was negative or where it was minus, it becomes plus. Then sine of x sine y. Sine y. That's how it looks like. So again, you can use that into different kind of situations, and solve different kind of questions. Now let's see for tangent. For tangent, we know that we have tan. For tangent, we have tan x plus y equals to what? Equals to tan x plus tan y over 1 minus tan x tan y. And where does that come from? You can be told to derive this. We know that tan is equal to sine over cosine, and then you will use this one and this one, and then you end up having that expression there. That is to say, if we try to do that much, we shall have the sine of x plus y cos of x plus y, and we know that this one is equal to sine of x cos y plus sine of y cos x over 1 over cos of x cos of y minus sine of x sine of y. And we can divide that by this factor throughout. Dividing that by that factor throughout, that means we are going to be left with sine of x cos of y cos of x cos of y plus sine of y cos of x divided by cos of x cos of y over this divided by itself is equal to 1 minus sine of x sine of y cos of x cos of y. And I will find that cos and cos goes, and then there we have We have also cos of x and cos of x goes. That means we are going to be left with tan of x plus y equals to what? Sine over cos is equal to tan of x plus sine of y cos of y. That means is tan of y. And there is 1 minus, we have sine of x cos of x, that is tan x. And then we have tan of y. That is a very simple identity to prove. So you can be asked to prove that, then it's very, very, very simple. But also sometimes you can have something like this. Let's say you have tan of x plus x, something like this. That means this is tan 2x equals to what? Equals to, there we can see it is tan x plus tan x, 1 minus tan x. That follows that tan 2x equals to what? 2 tan x, 1 minus tan square of x. You know, this identity is so much very useful while we try to integrate, and when we try to use t formulas. You know that we use this to prove the t formula. So that is how tangent looks like, plus with a plus sign in between. What about tan of x minus y? So you can use the same procedures and prove that and show that tan of x minus y is equal to what? Tan x then minus tan y, 1 plus tan x tan y, tan x tan y. So these are few identities that are major identities that of sine, cosine, and tangent. The one to subtract, the one to add, and those are the important ones. Now let's see what next. Now let's prove some few identities here. And we are told to prove that cos of alpha plus beta over sine of alpha cos beta is equal to cot of alpha minus tan of beta. Now let's prove that. So we are told to prove that cos alpha plus beta over sine alpha cos beta is equal to cot alpha tan beta. As I explained earlier in the previous lesson or in the last session, we are told to prove. That means we are supposed to take one side and use that one side to reach the second side. And use that side to reach the second side. That means we are not supposed to use both sides. Our question does not tell us to show. We are told to prove. That means we are to select a side. Now let's say a solution to that. Let's say from left hand side we have cos alpha plus beta sine alpha cos beta. This equals to what? Let's simplify that by the use of compound angles. This will be equal to what? We know that cos alpha plus cos beta is equal to cos alpha cos beta minus sine alpha sine beta, over, now it's over sine alpha cos beta, sine alpha cos beta. Let's simplify that once more. Then we have cos alpha cos beta sine alpha cos beta sine alpha sine beta sine alpha cos beta. As you can see, there are common terms there. There are common terms there. We have cos of beta, cos of beta. We have sine alpha, then sine alpha. That means we are left with cos alpha, sine alpha, minus, there we have sine beta cos beta. As we know that this is a reciprocal of tangent, that means for tan we are supposed to have a sine on top and a cos down. That means this is equal to what? This is equal to cot alpha minus this is now tan. So as you can see, these results are equal to that one. That means you are supposed to conclude, therefore left hand side is equal to right hand side, and then we have cos of alpha plus beta sine alpha cos beta is equal to cot alpha tan beta. This is how we conclude such kind of a question. This is how we conclude such kind of a question. Let's see the next example. And the next example tells us if a plus b is equal to pi over 4. We know that this is in radian form. Pi over, prove that 1 plus tan a in brackets times or multiplied by 1 plus tan b is equal to 2. As you can see the question there, that means we are supposed to prove. That means we are supposed to choose one side and use that to get the other side. Let's see how it goes. Okay, we have a plus b is equal to pi over 4. And we are told to prove that equals to what? 1 plus tan b, oh, it's tan a there, sorry. 1 plus tan b equals to 2. So how do we prove that? As you can see, we have tan. So can we open with tan? Can we open that by the use of tan on both sides? So we can apply tan on both sides. Then we are going to be left with tan of a plus b is equal to tan of pi over 4. And we know that tan of pi over 4 is tan of 45, which equals to 1. And this we know from the compound angle formulas is that tan of a plus b is equal to tan of a plus tan of b over 1 minus tan a tan b equals to 1. So if that is the case, then what next? Can we multiply this to that? Yes, we can do that. That means we have tan of a plus tan of b equals to what? So if we take all of that expression multiplied to that, equals to what? Equals to 1 minus tan of a tan of b. And our what we are supposed to prove is this thing here, the product of 1 plus tan a multiplied by 1 plus tan of b is equal to 2. That means all that we are doing, we are supposed to end up at that point. Now let's see. Can we take this one to this side so that there we are left with 1? Can we do that? Yes, let's try that. So tan of a tan of B, this is negative, then coming to this side of equal signs, to be plus tan of A tan of B is equal to 1. Oh, so we have something like that. What can we do next? What can we do next? Can we add 1 to both sides? Can we do that? Let's add 1 to both sides. So it will be tan of A plus tan of B plus tan of A tan B plus 1 is equal to 1 plus 1. It's a good practice to do that. Or sometimes you can write like this. You can write like this. You can write like this. Adding 1 to both sides of, let's say you call this is equation number 1. So you can say adding 1 into both sides of equation 1, what are we going to have? We're going to have the following. We're going to have tan A plus tan B, then plus A plus 1 is equal to 1 plus 1. So that if someone reads your mathematics can understands your steps, and we know that mathematics is these are mathematical statements. From one statement it should connect to the other statement. So this is how you can connect your sentences. Now let's see there. Can we take this one? Because we are supposed to find something like this. So can we take this one and that one together? That means we are going to have a 1 comparing to that thing there. We're going to have a 1 plus tan of A plus all of the left, that is left, and this is equal to 2. That is equal to 2. So what is next? Can we simplify this? Yes, we can do that. That means we are going to be left with a 1 plus tan of A plus tan, can we factor out tan B? Then we are going to be left with the 1 plus tan of A. This is equal to 2. So from that point, if there is 1, then you can take this one and that one. That means is 1 plus tan B, then 1 plus tan A is equal to 2. So you can see that result resembles that one, just because mathematical in mathematics we know that multiplication is commutative, then the results are the same. So if someone writes 2 times 3, we know that is equal to 3 times 2. This is how. So writing that way is the same as that thing there. Okay, my dear students, let's check the other examples. Now that was the example on how you can, that involves proving by the use of compound angles. There are a lot of questions out there, so you can find other questions and try to do the questions. But not necessarily that every time that you are told to prove, let's say the left hand side, let's say the left hand side is equal to the right hand side. Not necessarily that every time they should be the same. Sometimes there can be mathematical some errors, let's say in writing, whatever, even the signs or the letters. So sometimes it may occur that you can't reach the next or the resemblance. That means you have to conclude that the right hand side is not equal to the left hand side. That means this is not equal to that, or this side is not equal to the other sides. So you have to be careful. Not every question that you miss, it means that it's like that. Sometimes you have to follow your steps so that you can understand how it goes. Let's see the other examples. Now we have simplification of identities involving compound angles. Simplification of identities involving compound angles. For example, there we are told to simplify if x sine x plus alpha is equal to cos of x minus alpha, then we are told to find the tangent x. Find the tangent x in terms of alpha and beta. Then find tan x where alpha is equal to 45 degrees and the beta is equal to 60 degrees. And we have a hint there. We are told that leave your answer in sad form. Sad form. We shall see what is sad form. Now the question is, sine of x plus alpha is equal to cos of x. Then we are told that find this. We are told to find the tangent of x. Now, as you can see there, these are very simple compound angles. Now, how can we do that? Now, let's open those. So it will be, we know that sine of x plus alpha equals to what? Equal to sine of x cos of alpha plus sine of alpha cos of x, we are told is equal to cos of x minus beta. That is cos of x, that two compound angles, cos of beta, then minus, is it minus or plus? Plus sine of x sine of beta. We know that. So what can we do from there? We are told to find the tan of x. Tan of x. Oh. Now, can we collect like terms? Where there is a sine and where there is cos, that means this can go to that side and this comes to this side. Can we do that? Yes, we can do that. That means we have sine of x cos alpha minus sine x sine beta. That means this comes to the other side and this will go to the other side. That means we are going to have cos of x cos of beta. Then this to that side, it will be sine of alpha cos of x. Okay, oh, so we have like terms there. Can we factor them out like this? Then we are going to be left with cos alpha minus sine beta. And then we are going to be left with what? Taking cos out, cos of x out, that we are going to be left with cos of beta minus sine alpha. And remember, we are told that we are supposed to find this one. So how do we do that? Okay, now let's see. How can we do that? Can we divide that by dividing by, what can we divide there? The factor cos x times cos alpha throughout. And why have I decided to do that? Because I want to have a tan on that side. That means if I divide by cos on that side, that means cos will go. And on this side, it will be sine over cos. That means I'll be left with a tan. And if I divide with that factor on this side, this will go and that factor will divide the other side. That means before you do any of the steps in simplification question or proving question or showing question, you have to understand what will be next after that step? What are you going to be left with? What are you going to be left with so that you can simplify that to the intended thing? So as I've decided to divide by that because I know what I'll be left with. So let's do that. So we have sine x cos alpha sine beta divided by cos xc cos alpha sine beta is equal to cos xc cos beta sine alpha, then dividing by that we have cos xc, and then we have cos alpha sine beta. You can see this one and that one goes, and then in this side cos x and cos x goes. Then we are left with what? Sine of x cos of x is equal to cos beta sine alpha cos alpha sine beta. And we know that this side is equal to tan, because sine over cosine is equal to tan. Sine over cosine is equal to tan. So that side will be equal to tan of x equals to what? Equals to cos beta minus sine alpha cos beta minus sine alpha over sine of alpha minus cos of alpha minus sine beta. But remember, in a question we are told the following. In a question we are told that alpha is equal to 45 degrees and beta equals to what? Equals to 60 degrees. That is to say, tan x equals to what? Cos of beta, that is 60, minus sine of alpha, that is 45 degrees, over cos 45 minus sine 60. And we know that sine 60 equals to under 3 over 2, and cos 60 equals to a half, and cos 45 equals to under 2 over 2, and also sine 45 from special angles, and all of these are from special angles, is under 2 over 2. Under 2 over 2. So can we plug them there? Now let's do it. That means we are going to be left with a tan x equals to what? Cos of 60 is a half, minus sine of 45 is equal to under 2 over 2. All of this is over cos of 45 is under 2 over 2, and minus under 3 over 2. The question asked us to leave the answer into a sad form. That means let's simplify that and leave the answer in a sad form or sad notation. That is to say, tan x equals to 1 minus under root 2. If you take 2 as your LCM over 2, divide by what? Divide by under root 2 minus under root 3, and all of that is over 2. So if you simplify that once more, you will have the following. Because 2 and 2 will go, and then you'll be left with, and you are told to leave your answer in third form. So that is, the under roots are in third form. Don't go into your calculator and then find the value of square root of 2, square root of 3, and write the answers there. You were told to leave the answers into third form. That means your answer will be, someone else can go on and rationalizing that. Now let's see the next example. As it says, find the value of sine 15. As it says, let's see the next example. As it says, find the value of sine 15, tan 105 degrees, and so forth and so forth. Let's try to solve a few of those. So we have sine 15 degrees. We are told to find the value of that. Now, sine 15 is not a special angle. And in some other questions, you are told, you will be told to find the value of sine 15 without the use of calculator. Or sometimes you'll be told also to use, to leave your answer in third forms or in whatever. So how can you do that? Let's see. We know that we can get 15 from a very different way. You can take 60, let's say, minus 45. And those, both of them are special angles. So you can use that. Or you can use the other way if you think it will be correct. Try to think the other way if there is another way. That means we can say, instead of writing 15, we know that 60 degrees minus 45 degrees, this equals to 15 degrees. That is to say, if we try to open both the sides, that means if we try to open by sine both the sides, we shall have sine of 60 minus 45, and all of these are degrees, equals to sine 15. So this is what we were told to find, and then we have tried to use this way so that we can get the value of that sine 15. That is to say, sine 15 equals to what? Let's use the double angle formula. That is to say, we shall have sine 60 cos 45 minus sine 45 cos 60. And we know that sine 60 equals to under root 3 over 2. Cos 45 is equal to under root 2 over 2. And sine 45 also is equal to under root 2 over 2. And the cos 60 equals to a half. So let's see. So it will be sine 15 equals to what? Sine of 60, that is under root 3 over 2. Then it times what? Times cos of 45, that is root 2 over 2, minus sine of 45, it will be root 2 over 2, times cos of 60, that is a half. Now let's multiply that. It will be equal to what? It will be equal to under root 6 over 4 minus under root 2 over 4. That is to say, we are left with what? Under root 6 minus under root 2, all of that is over 4. This is sine of 15. So if you can simplify that much more than as where I've reached, then you can go on and simplify that. I do hope I'm correct there. Let's see, how can we find tangent or tan of 105? How can we do that? How can we find the tan of 105? That is to say, we have tan that way. What special angles can we add or can we subtract so that we can have 105? What special angles can we subtract so that we can have that one? As you know that if you take 60 plus 45 equals to what? That is equal to 105 degrees. That means there we can have tangent of 60 degrees plus 45 degrees. That is to say, we are going to have 105 as our tangent. Let's open that by the use of compound angles. We know that tan of A plus B equals what? Equals to tan A plus tan B over 1 minus tan A tan B. So if our A is equal to 60 and our B equals to 45, that is to say, we are going to be left with what? Tan of 105 equals to what? Equals to tan of 60 plus tan of 45 over 1 minus tan 60 tan 45. And we know that tan 60 equals to what? Equals to under root 3 from special angles. And what about tan 45? Tan 45 equals to 1. Equals to 1. So how can we manipulate that? That means we say tan of 105 degrees equals to tan of 60, that is under root 3, plus tan of 45, that is 1, over 1 minus tan 60, that is under root 3, times tan of 45, that is 1. That is to say, if we try to simplify that much more, we are going to be left with tan 105 equals to what? 1 plus under root 3, and then 1 minus under root 3. It is a good practice to rationalize that. It is a very good practice to rationalize that, so that the sides or the under roots or these signs are left on top. So if we rationalize there, we have 1 plus under root 3, 1 minus under root 3 times 1 plus, this is rationalizing factor, 1 plus, so we'll be left with what? 1 plus under root 3. You can see there they do resemble, so we can write square, or you can write 1 plus under root 3, and then these are equal to 1 minus what? Minus 3, which equals to what? Let's see. So we have tan of 105 equals to this, and that is 1 plus under root 3 over what? And this is squared, and this is equal to over negative 2. You can simplify that once more, which will be equal to what? Equals to 1 plus this times that one, then times 2, that will be 2 under root 3, then plus what? Plus 3, this is squared, and then over, so that we can remove that square there. That is to say we have a 4 plus 2 under root 3 over negative 2. Try to simplify that once more. That means we are left with negative, and all of that will be negative 2 plus under root 3. So that is tan of 105 degrees. Can be written like that, or like that, is still the same. Still the same. So that's how we find the values of such kind of angles. I will leave you some more questions, but I still insist. The questions that I'm trying to solve here are not the only questions that are out there. Find past papers, find questions, find other research, find books that are from the internet. Make much good use of the internet and find questions. Okay, you can do these questions for more practice, and you can prove that. For example, the question says prove that a cos of a plus b, cos of a minus b equals to that. You can just open, and then it's fairly simple. And then this question says tan of a plus b plus c equals to that expression there, tan a tan b plus tan a plus tan b plus tan c minus tan a tan b tan c over 1 minus tan a tan b tan b tan c minus tan a tan c. But also you can also use this question for more practice. That will be tan 45. That will be tan 45 plus theta over tan 45 minus theta equals to, in brackets, and that is all squared, 1 plus tan theta, 1 minus tan theta. And find other questions, as I said earlier. And up to that point, you were with Kimati, mathematics teacher. Please find more questions and practice, and be safe out there. Thank you.